Hello class, today we're going to talk about section 10.1. We're going to be starting chapter 10. Today we'll be adding and subtracting polynomials. So our learning goal today is we want to be able to add and subtract polynomials. Before we can do that, there's a lot of vocab we need to cover, all right? A full page of vocab. So let's talk about these. First, we want to talk about a monomial, all right? A monomial is when we have just one term. So a monomial is a number, a variable, or a product of a number and one or more variables with whole number exponents. A monomial is a polynomial with only one term. So if we have one term, let's say, well, let's start easy, just a number. Or if we attach a variable to that number, that's a monomial. If we make it 4x squared y, more than one variable, that's still a monomial, okay? If we want to get crazy, negative 256 x squared, y to the third, z to the fourth. This is still a monomial because it's just one term. All right? Now when we talk about the degree of a monomial, okay? The degree of a monomial is the exponent of the variable in the monomial. So if we have a monomial with just one variable, such as 5x squared, the degree is the biggest exponent. Okay? So it would be 2 in this case. If my monomial was 74 y to the 7th, okay, my degree would be 7. Next, a polynomial. A polynomial is a monomial or a sum of monomials. So, again, we listed a bunch of monomials up there. 3x, maybe 4x squared y, negative 256 x squared y cubed z to the fourth. Each one of these separately is a monomial. But if we then go ahead and combine these using plus or minus, it then becomes a polynomial, okay? So if it is a sum of monomials, it is now a polynomial. A binomial is when you have a polynomial, but there's just two terms. There's a common binomial, okay? So a binomial is when we have two terms. How many wheels are on a bicycle? 2, right? The prefix bi means 2. Let's keep going. Trinomial. So if a binomial means we have two terms, okay, so if a binomial means we have two terms, a trinomial means we have 3. Something like that. 3 separate terms, okay? How many wheels are on a tricycle? Tricycle? 3, right? So the prefix tri means 3. If they ask for a polynomial in standard form, you need to make sure that the exponents are in descending order. So what you should notice here is my exponents are going in descending order. All right? So 4, 3, 2, 1. If they ask for standard form, make sure your exponents are going in descending order. It doesn't matter what the coefficient is. Doesn't matter what the coefficient is, okay? All that matters is the exponent. And the degree of a polynomial in one variable, again, it's just the biggest exponent, so the degree of this one would be 4. All right, a lot of vocab there, a lot of vocab. Let's get to what we're actually doing in this section. So let's start by working with that vocab a little bit. Let's start with example 1. So what they want in example 1 is they want the degree. They want the degree of each monomial. So looking at part A of example 1, we have negative 2x to the 6th. The exponent on our x is 6, so the degree is 6. All right, we look at the value of the exponent. Here we have 3/7 y, okay, and again, if we don't have an exponent, it's really to the first power, right? So since the exponent of y is 1, the degree is 1. And if you don't have a variable, so like for part C here, we have just the number 23, Michael Jordan, right? If we don't have a variable, the exponent is technically 0, so the degree would be 0. All right? So always look at the exponent on our variable. If there isn't a variable, our degree is 0. So let's continue that. Here we're going to be identifying polynomials by degree and number of terms. Let's start with part A. So part A is -3, right? There's no variable, so its degree is 0. When we have degree 0, we call it a constant. Okay, when we have degree 0, it's called a constant. Then if we look at the number of terms, let's get a different color here. That'll work. There we go. If we look at the number of terms, there's just one term here. When we have one term, we call it a monomial. Okay, that prefix mono means 1. Great, let's keep going. This one, again, we look at our variable, okay? Our variable has an exponent of 1. Again, when it's not showing an exponent, we know it's 1. So this has degree 1. When we have degree 1, we call it linear. Okay? And if we define it by the number of terms, there are 2 terms here, so we call it a binomial. So this is a linear binomial because it's degree 1 and there's 2 terms. For part C, looking at our variable, this time we have a exponent of 2. So my degree is 2. When we have degree 2, we call it quadratic. And then if we look at how many terms we have 1, 2 terms, making this also a binomial. So let's look at the difference between the last 2 for just a second. We call this one a linear binomial because there's 2 terms and its degree is 1. But then C we call a quadratic binomial because, again, there's 2 terms making it a binomial, but this time our degree is 2. When our degree is 2, we call it quadratic. And last, part D, again, we look at the biggest exponent. My biggest exponent here is 3, meaning this is a degree 3. When we have degree 3, we call it cubic. All right, so since it's degree 3, we call it cubic. And then when we count the number of terms, we have 4. Now, here's the thing. When we have 1 term, we call it a monomial. 2 terms is called a binomial. 3 terms is called a trinomial. And then anything 4 terms or above, we just simply call a polynomial. Okay, so anything that has 4 terms or above is a polynomial. Okay? The prefix poly means many. Okay? So there's many terms. We didn't want to come up with names for 4, 5, 6, 7, 8, 9, 10, right? So anything above 4 is less common. Okay, we'll be mostly using monomials, binomials, and trinomials. But anything above 4, we just call a polynomial. So this is all just vocab. This is all just vocab. It's good to know. I need you to be familiar with this vocab, okay? Be able to tell me how many terms a binomial has, how many terms a trinomial has. If I say a function is linear, know it's degree 1. If I say it's quadratic, know it's degree 2. Cubic, degree 3, so on and so forth. But yeah, this is all just vocab. Let's get into the actual math we'll be doing today. So let's move down to example 3, where we are going to be adding polynomials. Now, we have 2 different ways that we can add these polynomials. We have 2 different ways. They are going to show us the vertical format and the horizontal format, and I'm going to let you decide which one you like best. Okay? I'm going to let you decide which one you like best. I want you to try both in the homework, but when it comes time to take a quiz or a test, I'm going to let you decide which one you want to use. But let's show you both anyway. So here's what we're going to do. We are going to add these two polynomials, so negative 3x cubed plus 11x squared minus 8x plus x to the fifth plus 2, plus 8x minus 2x to the fourth plus 7x to the third minus 3 plus 12x squared, which probably looks really, really intimidating. But after we clean that up and organize, you're going to see that it's actually not that bad. The key here is to combine like terms, okay? And here's what I mean by that. We can combine two terms when they have the same variable raised to the same power. So for instance, if I want to do 2x plus 3x, we can do that. We just call it 5x. All right? But if I have something like this, 2x squared plus 3x, I cannot combine those because they are not like terms. And the reason they're not like terms is because we have an x squared and an x. So you can only combine like terms if they have the same variable raised to the same power. Using that knowledge, you'll see, looking at example A here, that they line up the numbers a certain way. So our first polynomial, negative 3x cubed plus 11x squared minus 8x plus x to the fifth plus 2, you'll notice they wrote it in standard form. All right? They wrote it so that all the exponents are decreasing. The 5 goes first, then the 3, then the 2, then the 1, then the x to the 0, right? Then the second polynomial, they did the same thing. They rewrote it in standard form. And the reason they did this is once you write them both in standard form, we can then line up and add vertically, hence the vertical format. So x to the fifth plus the second, our blue polynomial didn't have an x to the fifth. So x to the fifth plus nothing is x to the fifth. Our yellow polynomial doesn't have an x to the fourth, so nothing minus 2x to the fourth is minus 2x to the fourth. Negative 3x cubed plus 7x cubed is 4x cubed. 11x squared plus 12x squared is 23x squared. Negative 8x plus 8x is 0, so we don't write anything. And then 2 plus a negative 3 is negative 1. And there we go. We have added the two polynomials together by combining like terms. X to the fifth combines with nothing else, so we're just left with x to the fifth. Negative 2x to the fourth combines with nothing else, so we're left with just negative 2x to the fourth. Negative 3x cubed combines with 7x cubed to give us 4x cubed. 11x squared combines with 12x squared to give us 23x squared. Negative 8x plus 8x cancels out. And 2 combines with a negative 3 to give us a negative 1. That's the vertical method. Now, our other method is the horizontal method. And let's do that for our second example. So in this one we have 3x squared minus 2x plus 3 plus x plus 4x squared minus 1. And what we want to do is we want to group like terms. So 3x squared will group with 4x squared. So 3x squared plus 4x squared. Negative 2x will group with positive x. So we write negative 2x plus x. And last, 3 combines with negative 1 to give us 3 plus negative 1. And then we just need to simplify each one separately. 3x squared plus 4x squared is 7x squared. Negative 2x plus x is negative x. And 3 plus a negative 1 is 2. Now, if I'm being honest, I prefer the horizontal method. I like writing my two polynomials out and then grouping the like terms. Okay, so grouping 3x squared and 4x squared to give me 7x squared. Grouping negative 2x and x to give me negative x. Grouping 3 and negative 1 to give me 2. All right? That's the way I typically do it when I'm doing these problems. Great, let's keep moving. Now, the title of the section was adding and subtracting polynomials. So, we need to learn how to subtract. Example 4, and this one will be subtracting. It looks like we'll be subtracting using the vertical method. Let's do it. So we're going to use a vertical format here. Now, you all know I don't like to subtract. I like to instead add the opposite, okay? And we're going to do the same thing here. So we're going to use a vertical format, and to subtract one polynomial from another, we are going to add the opposite. Add the opposite. Okay? One way to do this is to multiply each term in the subtraction polynomial by negative 1. Then we line up the like terms vertically, and then we add. So let's do that. So, instead of doing 11x to the fourth plus x cubed minus x plus 5 minus all of this, here's what we're going to do. We are going to change this to an addition, and then we're going to multiply every single one of these terms by negative 1. Alright? So, negative 1 times negative x to the fourth is positive x to the fourth. Negative 1 times negative x squared is a positive x squared. Negative 1 times positive 2x is a negative 2x. And negative 1 times a positive 8 is negative 8. So what I did is I changed the sign on all of these. Instead of negative x to the fourth, I have positive x to the fourth. Instead of negative x squared, I have positive x squared. Instead of positive 2x, I have negative 2x. Instead of positive 8, I have negative 8. And then we just add these all together. 11x to the fourth plus 1x to the fourth is 12x to the fourth. X to the third plus nothing else is just an x to the third. Nothing plus x squared is just x squared. Negative x plus negative 2x is negative 3x. And 5 plus a negative 8 is negative 3. Alright? So that's how we would do this using the vertical format. In the checkpoint problem below, I'll show you how to do this using the horizontal format. But first, let's look at the first checkpoint. So here we have an addition, and here's what I'm thinking. I am going to rewrite both of these polynomials in standard form, okay? I'm going to rewrite both these polynomials in standard form. You know what, even better, looking at this, they both already are in standard form. So let's go ahead and just add these together, and we're going to do the horizontal method. So let's start with 2x to the sixth. So I have a 2x to the sixth. Okay, all I can combine with that is the other, looks like there's no other x to the sixth, so that one's going to be all alone. Next, let's go to x to the fifth. I have negative x to the fifth. Then I have a positive 7x to the fifth. Next, any x to the fourths? Yep, I have a negative x to the fourth. Next, x to the third, I have a 3x to the third. And I have a 9x to the third. Okay, now to x to the second, I have a negative 14x to the second. I'm running out of space, but that's fine, we'll make it work. Plus a 13x to the second. Then I move on to just x's. Doesn't look like I have any x's. You know what? I'm going to make this magically better. And I fixed it. Okay, I just made it a little bigger, okay? So here's what I did. I combined, right, I grouped all of my like terms. My 2x to the sixth, there's no other x to the sixth, so I can't combine that with anything. Negative x to the fifth, and then looking down here, there's a 7x to the fifth, so I grouped those two. 3x cubed, I'm sorry, we need to go to the x to the fourth next. Negative x to the fourth, there's no other x to the fourth, so I can't combine that with anything. Then my x cubes, 3x to the third plus 9x to the third is grouped here. Negative 14x squared plus 13x squared is grouped here. And then just my constants, 13 plus 2, grouped there. Now I just need to simplify each grouping, and I'll have my answer. 2x to the 6th plus nothing else is 2x to the 6th. Negative 1x to the 5th plus 7x to the 5th is 6x to the 5th. Negative x to the 4th combined with nothing is still just negative x to the 4th. 3x cubed plus 9x cubed is 12x cubed. Negative 14x squared plus 13x squared is negative 1x squared. And then 13 plus 2 is 15. And that's our final answer. We cannot combine anything else past this because they all have different exponents. And finally, checkpoint number 2. And this one is a subtraction. And let's do this subtraction this time, the horizontal method. So here's what I'm going to do. I'm going to rewrite this first polynomial, and I am not going to change a thing. Didn't change a thing. Here's where the change comes. Instead of doing minus our second polynomial, I'm going to make this a plus. Okay, but we can't just change it to add. We need to make sure that we add the opposite. So I'm going to need to multiply every single one of these terms, by a negative 1. All right, so I'm going to distribute this negative 1 to every single term. Let's do that. So again, my first polynomial is unchanged. My first polynomial is unchanged. This is now an addition, and then I need to multiply every term by negative 1. All right, every single term. So, negative 1 times x to the 5th is negative x to the 5th. Negative 1 times negative 4x to the 4th is a positive 4x to the 4th. Negative 1 times 11x is negative 11x. Negative 1 times 11x squared is negative 11x squared. Negative 1 times 2x is a positive 2x. And negative 1 times negative 7 is a positive 7. And now what we have is an addition problem, so we can complete it exactly the way we did before. Let's group like terms. So it looks like my biggest exponent is 5, so let's start with that. I have a 3x to the 5th, and I have a negative x to the 5th. Any x to the 4ths? Yes, I do. I have a 4x to the 4th. Any x to the 3rds? Yes, I do. I have 7x to the 3rd. And no other one. Any x squareds? Yes, I do. I have negative 13x squared and a negative 11x squared. Any plain old x's? Yes, I do. I have negative 10x and a 2x. And then any constants, I have a 9 and a 7. So all I did here was I grouped like terms. Now we just need to simplify. 3x to the 5th minus 1x to the 5th is 2x to the 5th. 4x to the 4th plus nothing else is just 4x to the 4th. 7x to the 3rd plus nothing else is 7x to the 3rd. Negative 13x squared minus 11x squared is negative 24x squared. Negative 10x plus 2x is negative 8x. And 9 plus 7 is 16. So as you can see, the toughest part of these, honestly, is keeping it neat and organized. Okay? If we keep it all neat and organized and we show all our work and then we group them all together, it's just an addition and subtraction problem. Okay? You need to stay neat, stay organized, and remember like terms. We can only combine terms that have the same variable raised to the same power. Notice I can't go any further than this because we don't have the same variable raised to the same power. All right, get your homework going.